the formula. For that, we are making a relationship between slope theta. So definitely the structure will get, you know what is the slope? Change in vertical axis dy by dx or tan theta. It will make some angle. And deflection at any point due to the load, what is the maximum deformation or the deflection occurs? And what is the radius of curvature? At any point, the beams get curvature bending at the origin or the centroid point. We have the curvature. Let us take this AB as this AB. So AB I will draw here, AB. Due to the bending, I will say as a sagging, it will get like this bend. So I am taking AB a beam and I am bending like a AB bending. So if you draw a curvature line, then from the C point, you will have the D alpha, right? And if you see, if you draw the tangential line from the A point, this without bending, it will go alpha. After bending, the B point tangential will be alpha plus D alpha. A small portion of AB of a beam bends in a arc. That means we are bending in a arc. It is sagging. So ds is the length of the beam. We are taking this length is a ds, and C will be the center of the arc into which the beam has been bent. Right. So this make an angle alpha, and it is tangential to the A. That means A point. A point is alpha. B point is alpha plus D alpha. Let us take from this picture. So from this triangle ACB. So triangular is it is D alpha angle. So from next ds is equal to R by R d theta. That means this arc will be ds length will be purely depends upon what is the length of arc, that is d alpha into the distance r. That is what ds equal to r into d alpha. So then we are making r equal to ds by d alpha will go this side, and this we are making this before it is in ds. After bending it will come dx and dy in x and y axis. We are replacing s as dx. Then this r equal to dx divided by d alpha. So we know that we have to make 1 by r. So you replicate this d alpha by dx. This term will change. So now you take from the diagram, take the tangent, right? Tan alpha equal to dy by dx. This is slope. Dy by dx is slope. So tan alpha is a very, very small angle. So we'll make it as an alpha. So alpha is equal to dy by dx. Right? You know only term is in the angle of this diagram. Alpha equal to dy by dx. You do the differentiation once again. So d alpha by dx. This term will come dx square by dx square. dy square by dx square. We get d alpha by dx equal to dy square by dx square. Now we got the value of alpha dx by dy. Already we have the d alpha by dx equal to 1 by r. Right? You replace it here. 1 by r equal to d square y by dx square. Now from the pure bending equation, pure bending theory equation, we know this formula. Kindly note down this formula. Sigma by y, m by I is equal to E by R. Sigma by y is equal to m by I is equal to E by R. So what is sigma? Bending stress, distance, bending moment, moment of inertia, Young's modulus, radius of gyration. Right? So from this we will take this combination, m by I equal to E by R. From this combination we make moment equal to I will go this side, EI divided by R. So this is 1 by R, we know d square y by dx square. So here E into 1 by R will be d square y by dx square. So we got a combination of equation in terms of moment is equal to EI, metal property, moment of inertia, d square y by dx square. The above equation is based on the only pure bending. So this equation we derived only for pure bending, not shear consideration. Right? So you have to remember for the beam calculation, you have to remember this formula m equal to. Why? Because you are taking a beam and you are applying a bending. Either you are applying a point load or UDL, or you makes to bend, applying a like twisting like this, you will apply a bend. Right? So you apply a momentum at the ends. Though this is bending for the aeromechanics of solids, we used to make the sign conversion of the slope and deflection. So we need to understand how we are placing the sign conversion. So to find out the slope and deflection of a center line of any beam, maybe a cantilever beam or fixed beam or a simply supported beam. So we have to deflection to find that in center line of the beam at any point. Proper sign conversion we will have to take in account. Why? Because sign conversion makes a sense that whether this beam is bending in a hogging or sagging. So whether which direction we are calculating. So one end, for example, if your beam is in cantilever beam means whether you are calculating from the fixed end or from the free end, right? That is the important things you have to note down in the sign conversion, right? So sign conversion will be used one as x is positive when measured towards right. Let us take this in a diagram. If you take the x direct, if you need changes in x axis mean you have to take the positive value when it should measure from the right side, right? If you only think that only if you go for right side, then it will go for a positive. Y will be negative when measured in a downwards. If you measure that the load will be in downward means this y will be in minus. Kindly note down. Y will be negative when measured in downwards. That means bending happens in downwards means we have to consider that is a minus sign. So bending moment is negative when hogging. What is hogging? I told already. Bending moment alone. So this is sagging, this is hogging, right? So bending moment, this will get m equal to minus. Here m equal to plus, positive. When hogging occurs, that is bending moment m is negative when hogging. Slope is negative when rotation in a clockwise. If this is in clockwise rotation theta, then this theta will be in negative. You have to remember, not in the anti-clockwise. So two things that this is, let us take this is A point, this is B point. If this is bend, at the A point you have angle, right? Theta. This will be negative. But why? Because it is in bending in a clockwise. Rotation in a clockwise means it is negative. This term you have to remember. X will be positive when measured towards right. Y will be negative when measured towards downwards. M is negative when is hogging. Slope is negative when the rotation is clockwise. So you will understand while solving the equations or derivation, that time you understand what this means in sign conversion. Right? So we identified a relationship between slope, deflection and radius of curvature, that is theta, y and r, and also we got the equation m equal to ei d square y by dx square, and we made the sign conversion for the problems. Now we are